So for example 1, for evaluating expressions with inverse trig functions, we have arc cosine of 7 pi over 6. And so I prefer to use the notation that looks like this. So I'm just going to rewrite it, and you don't have to do that. It's just a preference. And so whenever you evaluate an expression, remember you got to do the inside first and then work outward. So the first thing I want to do is evaluate cosine of 7 pi over 6. And if I look at my unit circle and I open up an angle of 7 pi over 6 radians, and I look at the x-coordinate of that terminal point, the x-coordinate is negative square root of 3 over 2. So I have that cosine of 7 pi over 6 is negative square root of 3 over 2. And so now we're dealing with evaluating an inverse trig function. And if you recall, inverse functions in general, what you're doing is you're switching your inputs and your output. And when you're talking about a trig function, typically you plug in an angle, whether it's in degrees or radians, and you get out your ratio. And so, or your x-coordinate or y-coordinate of your terminal point on the circle in this case. And so when we switch the inputs and the outputs, what we're doing is we're plugging in that ratio or that x-coordinate of the terminal point on the unit circle, and what we need to get out is an angle. So what we're going to get out here, our output's going to be an angle. And because cosine is not a one-to-one function, we need to restrict the domain so that when we take the inverse itself is also a function. And so when we restrict the domain of cosine and the domains and ranges get switched, what happens is your range is going to only fall between a certain set of numbers. And for cosine, it's going to fall between 0 and pi. So we're only going to be looking at the first and the second quadrant when we're dealing with inverse cosine functions. So when I look at the inverse cosine, and I want to find the inverse cosine of negative square root of 3 over 2, I want to look at my unit circle, but I only want to look at quadrants 1 and 2. So in quadrant 1 and 2, the angle in radians that would give me an x-coordinate of negative square root of 3 over 2 on the unit circle would be 5 pi over 6. So this would be my final answer because I take the inverse cosine of negative square root of 3 over 2, and that would give me an angle of 5 pi over 6.